Now, if you were asked to find the distance between two numbers, and I gave you two positive numbers on a number line, what's the distance between 13 and 15? 2. And you can just see it in your head and do it, right? Now, if I told you what's the difference, and I allowed your calculator, between 97 and 382, what would you do? You do 382 minus 97. If you wanted to find the distance between them, you would subtract. And you would naturally subtract, because you know about positive numbers very well, the big one minus the small one, okay? I don't think when I said, okay, first of all, when I said, what's the distance between 13 and 15, many of you just, boom, saw 2, okay? Some of you might have went 15 minus 13, oh, that's 2. You might have done the subtraction. Probably most of you just saw it. But I don't think anybody did 13 minus 15. Because if you want to find the distance between two things, you take the bigger one and subtract the smaller one. That makes sense. But sometimes our brains get a little mixed up, okay? Negative numbers can do that. When you see negative 3.7 and negative 8.5, it's not intuitively as obvious to see that the negative 3.7 is bigger. Your brain likes 8.5 because it looks bigger, so your brain like wants to first say 8.5 is bigger, and then you're like, oh, it's negative, so I gotta, and then, oh, okay? But if we want to find the distance between any numbers, notice that when I did 13 minus 15, I got minus 2, which is 2 is the right answer. I just got the minus in front of it. So if you're not worried about which one's bigger or smaller, right, to find the distance, easy, okay, I will write it down. It's going to be the bigger one minus the smaller one. That makes sense. But we can also find the distance by taking whichever way we want. I'm going to use A and B. Pick one as A, one as B. And if you put it in absolute values, even if you did it smaller minus bigger, the absolute values will make it positive, and you'll get the right answer. So it can take some thinking out of it. I could do, in the first one, for example, if I just don't want to think about which one's bigger, I could just put absolute value and then just take, oh, I've got 3.7 minus negative 8.5. And when I solve that, or when I figure that out, that becomes absolute value of 4.8. Oh, I did pick the bigger one minus the smaller one because I got a positive value inside, so it's equal to 4.8. Can we see on the number line if this is 0? Here's negative 8.5. 1, 2, 3. Here's negative 3.7. That negative 3.7 is bigger than negative 8.5. But had I done negative 8.5 minus negative 3.7 and kept it in absolute values, I would get 4.8 as well. So it's just a safety net for you, okay? Right, this one, it's pretty obvious which one's bigger for part B. That I can put it in absolute value, but 4 2/3 is definitely bigger than negative 5 3/5. But I could put it in absolute value bars to figure it out. Number one thing with absolute value bars, though, is you can't just change symbols inside. You still have to think of them like brackets. Simplify inside first, then change things. So you, for example, in A, you can't change this negative in front to a positive 3.7. It's only finding the distance to 0 after you've done all the operations inside. Now, little review of fractions. How do you add and subtract fractions? First of all, Can you see that the inside here would be 4 2/3 minus a negative is adding? How do you add fractions? Okay? I will show you most common way that happens in math. The most common way that happens in math, especially with mixed fractions, is changing things to improper fractions. Okay? As an improper fraction, can you see that 4 2/3? Well, 4 times 3 is 12. 4 is like 12 over 3 plus 2 more over 3 makes 14 over 3. And 5 3/5 would be 5 times 5, 25 plus 3, 28/5. And then in order to add fractions, you need a common denominator. So the common denominator between 3 and 5 would be 15. So I multiply top and bottom by 5 there, top and bottom by 3 there, and 5 times 14 is 70 over 15, plus 3 times 28 is 84 over 15. Add those together now. Now adding fractions, when you have a common denominator, you add your numerators. So we get 154 over 15, which is positive, so it's going to be 154 over 15. If we change this back to an improper fraction, how many 15s go into 154? Well, 10 of them would be 150, and you would have 4 left. This is the most common way people add fractions. Okay? For adding fractions, though, adding mixed fractions, some of you are going to like this better. Okay? The reason this is a little bit better, did you see how big of numbers we got? We got like up to 70, 84. That's like on the edge of, can't count that high, right? So if you like working with smaller numbers, 4 2/3 is 4 plus 2/3, and 5 3/5 is 5 plus 3/5. This method works good for adding, not always so good for subtracting, so be careful if you also want to use it for subtracting. Think about it lots. But if I do it this way, can you see that 4 plus 5, that would be easy to get 9? And then if I make the 2/3 and the 3/5, common denominator 15, 2/3 is 10/15, 3/5 is 9/15. That would give me 9 plus 19/15. Well, 19 is more than, right? That's going to be 1 4/5. Well, the 1 plus the 9 gives me the 4/15. I can get 10 4/15 with only up to 19. I can count up to 19, maybe better than I can count up to 84. Oh yeah, I'm going to get you to circle questions 5 and 8, but we're going to do the next example right away.